Today's session will talk about VPC, the VPC components, and how can we design a VPC from scratch. What are the things to keep in mind for well architecture, and also scenarios around like if you have multi account organization structure. So then how can we use it more? So if you visit of any of the architectural diagram, you would be seeing something like this, saying that it's something called AWS. If I go with AWS VPC, for example, in an diagram, you would see something like this, the outer architecture, and then you would see something around the internal architecture called VPC. Any architectural diagram, you would see something like this. The first one called as AWS, and then the local one would go as the VPC. So what they say is, whatever the architecture you are designing, it's within the AWS, and then you are adding one more level within that called as VPC. So any components you place within here, it's not going to communicate outside, even the resource exists in a AWS. So for example, you can have an EC2, you can have an S3, and there can be another S3 over here. So in that case, even both the resource exists in the same account or same region, but if it's outside the VPC or of different VPC, then it can't directly connect by default or directly communicate by default. So that's what this architectural diagram, whichever you refer, would refer to. When we talk about VPC, by default, AWS provides us the VPC for each individual account. You can go into search the same component of VPC, and the default VPC would consist of basically all the things you would need. If you go for the VPCs, you would be having the default VPC, see like which account owner ID and what are the CIDR and all those components would be seen. The same way, it would be creating a default options of DHCP, elastic IPs. If you're using anything that you procure, you're also having a default route tables and more. So these are the generic components, whichever you see it in the left side portion, which would becomes as part of the networking in generic. So now let's go ahead and try creating a new VPC. So if I go and create new VPC, it's going to ask about the name tag. So let's keep it as VPC. And then it's going to ask us two major parts. One is the IPv4 CIDR and IPv6 CIDR. So if you know about the IP address or how it translates, so you have two versioning of IP address, V4 and V6. As of now, still most of the architecture lies in V4, and very few are adapting to V6 due to many specific reasons, like in few versions of Nginx, they're not supporting V6. So most of the components, they would go for V4. And then let's try creating one. So first we'll try to start creating a IP address. I'm going with the range 10.0.0/16. So you don't need to worry about it. So you can go with like IP range calculator. So you have something, many tools available out there. So let's say I'm going with this. And if I go with 16, if I calculate it, so then it gives us the range. So like what is the maximum range, and so totally it's going to consist of, is it 65,000? Yeah, 65,534 IPs over there. So which means you can have like 10.0.0.1, 0.2, 0.3. Likewise, if it goes, then you are going to get the host total of this much number of IPs. So when you create a VPC, you're going to provide a overall of CIDR. So let's create a VPC now. So the VPC has been created, and what is the name we given for the VPC? I gave it as VPC. So now next we want to do is, you would generally split into your architecture, because your architecture would consist of web servers, like which would be like public facing, let's say EC2, and also it consists of servers that are used for database, which you don't want to expose to outside internet. So as I was saying, if your resource is within VPC, it can communicate to each other. But what if it's both being kept in the same scenario, and if someone can access your VPC from outside internet, they would be end up getting access to both the face, right? So to overcome that, you have something called subnets. So you have a CIDR, which is like a range of IPs, and then you can say if the IPs is allocated to an EC2 instance of this specific range, treat it as a individual subnet, and if a specific range of IPs mapped to DB, treat it as a specific subnet, and then how the traffic gets routed, right? So like from EC2 to internet, or from internet to EC2, how AWS can route it is based on a component called route table. Okay. So this is how the entire flow works. So now we have a VPC created. So once you create a VPC, what it would do is it would create 3 components. One, the default DHCP options which you have in place. And then you would have something called NACL, Network Access Control List. This would say if any subnets which is mapped to your VPC, what are the things can be allowed to the specific subnets. You can control it using the NACL. So if you see, this is the VPC which we created, and there is an equivalent NACL is being created by default. There is also one more thing which will be created. So we talked about DHCP, we talked about the NACL, and then there is one more which is called route table. So how the routing is going to happen. So it's going to create a route table for you also. So for our case, our VPC ID is this one. And if I go to the route table, if I refresh this, we could see there is a route table, the default route table being created for this. But then now we can't stop here. There is no specific subnets being created by default. So we want to split our entire VPC into like multiple networks. So how do we do that? We do that using a creation of subnets. So subnets are generally used for 2 specific purposes. One, you would say this specific subnets is meant for a public connection. You can also say this subnet is meant for private subnet. So this is one of the use case, so that you can categorize the subnet into public and private, and based on the resource component you are going to use, you can launch it in the specific subnet. This subnet is specific to availability zone. So you know that like the North Virginia, for example, US East 1 is a region, and this will be consist of multiple availability zone like US East 1A, US East 1B, likewise. And for the architecture perspective, to make it more reliable, let's say what will happen if one of the availability zone gets failure, we want to get it back by the another availability zone which will be up and running. So if I want to launch a EC2 instance, for example, for my application in the same region, but if I want to launch it in 2 different availability zone, let's say availability zone A and availability zone B, then in my architecture, for the public subnet, I would need 2 subnets. So a single subnet can be mapped to a specific availability zone A and availability zone B. Then I would need 2 individual subnets. Okay, let's go for the same console. Go to subnet, create subnet, and select a VPC. So the one which is us, which we created, and let's name it as public subnet. And here it's going to ask you for the availability zone. So if any EC2 instance, let's say, if it is getting launched using this specific availability zone, it's going to be get the IP address of the range which you're going to provide it here. So you want to come up with the range. So let's give it as a range of something like this. So if I calculate the range over here, /24, if I calculate it, so you're going to get like total of 254 IPs you're going to get from this specific range. So this range calculation itself will be a different topic. It's going to vary from your own application or architecture, but then you would generally map the specific range, and this subnet should becomes as part of the within this specific range, so that the CIDR has a made wider IP, and then the individual subnet will becomes as part of individual part. So let's keep it as 10, the public subnet. So I'll keep it as public EV availability zone A. Let's also create one more subnet. Same VPC will go. I'll keep public zone B, and let's keep USC 1B, and instead of 20, let's keep it as 20, and let's create a subnet, and let's create one for create a subnet, and let's keep it for private subnet one create. Use USC 1A, and let's keep it as 30, and let's create. So now we are creating 3 different subnets, and if you talk in terms of perspective, we are not saying like we just named it as public and private, but ideally the way of creation, it's exactly the same process. So how are we going to distinguish the subnet whichever we map is itself public subnet, and whatever we done is a private subnet. So if back to the architectural diagram, so if we see, we said that the routing is going to happen via here. So how this routing would happen? It's based on a component called internet gateway. So there are going to be like two specific individual services we would talk about. So one we call it as internet gateway, the another one they call it as NAT gateway. So the major difference between the internet gateway and NAT gateway is internet gateway is two-way. It lets you to connect or communicate from internet to your instance or resource, likewise from your instance to internet. Whereas NAT gateway, it's one way. You can ask for any information to the internet and internet will respond, but no one can initiate a communication from the internet to the backend. So let's say an example. So you have internet gateway, and then you have, so in internet gateway, I can initialize an SSH connection request connected to the web server. Whereas in NAT gateway, I can't initialize a request from the internet. Whereas if the EC2 instance is asking for some, let's say, a software package download, those kind of things can be achieved via NAT gateway. So both the internet gateway and the NAT gateway should be lying on the public subnet of the VPC. Okay, so when you are going to place create an internet gateway or create a NAT gateway, you want to place it in the public subnet. Keep that in mind. So how can we create an internet gateway? So can you use a default internet gateway? In general, don't use a default internet gateway because that will be associated with the specific VPC. So if I want to create a custom internet gateway, let's keep it as EVC internet gateway, and let's do that. So now the internet gateway is ready. Now, as you could see, there is no VPC being attached. So how can we do that? You can go actions, attach to VPC, select VPC gateway. So that's how you can attach a VPC. So now what we have done in architecture, we created a VPC and then we have added it here. So let's go for NAT gateway, create a NAT gateway, the NAT, and so it's going to ask for subnet, ensure to give public subnet as the way, and here you would need to allocate elastic IP so that it can allocate an elastic IP that is be launched and create NAT gateway. So that the NAT gateway is associated with an elastic IP, and now you can do it. So now if you see again coming back to the architecture, so now we have created an internet gateway, now created a NAT gateway. How can we know, like, if subnet A is being accessed, how can it connect to the internet gateway and how can it connect to this specific database part? So for which what we are going to do is, that's where the routing table comes into picture. So when you create a new VPC, it's going to come with a default routing table. If I go into the routing table, you could see it just says destination is this and local target, and there is no routing configured for any specific. So what we can do is you can create a route table, and let's keep this one for public purpose. So now again you need to choose the VPC and create route table. So again, we are not explicitly mentioning anywhere like how the routes are get configured. So next step you want to do is you want to configure route. So how do we do that? You go here, add route. For any part, you would say go to the internet gateway, and then the internet gateway will be created. So now what we have done is we created a route table, and then we configured a route saying that, okay, this is the destination for all the one to the internet. So now if you go to the subnet association, there is no direct association is being in place. You can go here, edit association over here. You can go to subnet and let's say public A, attach, and then you would be having like edit route table association. You can say edit route table association and then change it from the main route table into the specific one so that it has the highest priority. So more granular you apply, it's going to get routed over here. So same way, we want to create a route table for the private one so that we establish the connection between via the NAT gateway part. So how can we do that? You would go same way, the VPC part, then you created the private one. Now go to the subnets, choose the private one, and again edit route table settings, and then you are going to choose the private route table. So if you see in the private route table, we haven't enabled the routing for NAT gateway. So let's do the same thing which we did for internet gateway. So say likewise, you are just going to look for the NAT gateway and the one which you created and save this. So that's how you are saying, okay, this is the VPC, these are the subnets, and if something is launched over here, you are establishing the connection over here. Now, it doesn't stop if you already know the security components of AWS. There are two more components involved, which is NACL and the security group. So there are like multiple purpose for each component or individual use case you have for each component. In generic, you establish a security group for letting it allow the specific port. For example, I have a port 22, then I'm saying that from XYZ IPs, they can access the port 22, whichever the security group is mapped to the resource. So for example, I have an EC2 instance, then I want to get it connected via an SSH. So SSH is something like login into an instance from public internet. So then I would be mapping a security group on top of this EC2 instance, where I would say, let it allow the port number 22. The default ports you would need to keep in mind, which is TCP port 22, which is for connecting to your instance from outside. It's called SSH. Then you would need to know the port number for HTTP. If you're hosting a web server without a certificate or like unsecured website, then you would open port number 80. If you're launching your instance with a public certificate, for example, you could see here, right, Accelerator having a lock symbol with HTTPS. So this would be coming with a port number 443. So these three are like most common ports anyone should know when you are dealing with security group. And based on the nature of instance, so if you want to use a jump server and then connect it with the EC2 instance, it would open the port 22 only for the specific one. I will talk about the jump server as well in few minutes. So then you have NACL. So NACL is specific to subnets. So the security group is mapped by instances, right? Like EC2. Whereas NACL is mapped to subnets. Whichever the subnets we are creating, it will be associated to the NACL. And then we can control who can access the specific subnet. And then the major difference between security group and NACL is, so security group by default would be denied. And then you will be adding an inbound rule to say allow specific port from specific source. Whereas in NACL, you are going to consist of two rules. One as inbound and outbound. So when we say inbound and outbound, think it from the, let's say, EC2 instance mapped with a subnet. And this subnet will be associated with the NACL, right? So now when we say inbound rules, anything from internet or outside connecting to the EC2 will consider as inbound. Anything that would go outside or any request that goes away from the EC2 or any specific resource, those components we call it as. So when you are framing a rule for NACL, inbound, outbound, so those things you would be keeping in mind, like from which perspective you want to open a specific port or allow a specific IP, and do you need both inbound or outbound? Again, you would go with the most granular approach rather opening it for like multiple more wider access part. So we talked about internet gateway, we talked about route table, we established this connection over here. If you are creating a, if you're managing a multiple organization account, so in our case, like we have 4 accounts managed, and if you want to establish connection from one account to another account, it can be like one account is managed by data team and the another one might be managed by storage or accounts or some other team. And if you want to connect both ways, one way would be creating 2 VPCs, which you might be already knowing it, like you create 2 VPCs and then you will be establishing connection pairing between 2 so that they can communicate. This can create some chavos because there are certain primary requirements when you want to enable pairing, because the subnet should not be repeated in both the ones. So you can go to the subnet and then there is something called share subnet. So you can go here, share subnet, create resource share, and you can share the same subnet across the account. So You can go with the selected resource and you can provide specific who can access the specific subnet. So for example, I can keep public subnet, resource type would be subnets, and I want to keep the public subnet. And let's go for next. It gives you the specific permission set. So let's go for default permission set for now, and which principal or which account. So I can keep organization, which means all the accounts that are part of my current organization, it can get it. So you can get the organization ID by going through the control tower. So you have already made a separate session on like, so you would be going to the organization, fetch the organization ID, and then you can also mention like who can access your subnet, by which you can launch the instance in the same subnet from the another account, which is part of your own organization. So that you don't need to worry about is the subnet range which other team is saying is like, is it conflicting, or how can I manage or establish connection across. So when you are designing a VPC across the organization, you also have like allow sharing with anyone, allow sharing only within your organization. Like the networking part made more simplified with this option of sharing your subnet and sharing your VPC. So you create one VPC at company level, you create subnets based on your specific use case, and then just share it out. So that you go into the another account, you don't need to worry about like what VPC should I configure, and all those hurdles can be avoided. You don't need to worry about enabling VPC pairing. Any new account you launch, it's going to be that by default because you are already sharing the subnets parts across your organization. So that's the added advantage you get as from a network admin perspective, or when you want to design a solution. Else you would have seen like there are like multiple rules that comes as part of dealing with subnets. So this is the basic components you would need to keep in mind when designing the architecture. So I can show you like if you go to the EC2 instance page. So here you would see like if I try to launch an EC2 instance and you to ask for details like which VPC should I launch, right? So if I go edit, it's going to launch by default. Now you can precisely say like I want to launch within the specific VPC. So now you can control like that separate service called service control protocol. We can talk about in a separate session as well, where you can ensure or restrict users on the specific account to launch only in your custom VPC or not any other VPC. You can do that. And then you can choose the specific subnets. As I said, if you are going to choose this specific subnet, it's going to launch an EC2 instance in US East 1A. If you are going to launch use subnet B, then it's going to launch the instance in US East 1B. If you're designing architecture, then you want to think about how many availability zone you want to spread across, and that many subnets you want to create as part of your VPC for your public and private need. You have auto assign public IP because if it's a web server, then you would need to enable it so that it can automatically assign a public one. And let's say create security group, for example, you can create it. As I said, it depends upon your need. Do you want to enable SSH, or you can remove it? You can add a specific rule for HTTP, HTTPS. So all those components will be here. And the security group is just inbound specific. You don't need to worry about outbound part. Where else, if I go with the NACL setup, let's go back to the subnets or the VPC part. And if I go to the NACL and the one which is associated with here, and you can see it consists of both inbound and outbound. So, and also it consists of the priority like 100, 200, and you can also configure both allow and deny. So when it comes to security group, by default, it's going to be deny, and you're going to add rules, which is just to allow a specific port. Whereas in subnets, you can have both inbound and outbound, and based on the priority, you can play with it. And here also have the subnet association here. So I can create a NACL. Let's say I want to create it for public. Select a VPC. Again, just create a network ACL, and then I can go here. You can edit inbound and outbound, or you can also change the subnet association. So instead, I don't want to keep this, and then you can play with it, like what are the things you want to keep associated and what you don't want to keep associated. For example, now you just have only 2, right? So you have the flexibility to play each and every components. You just need to know what is the need for your organization and how we are going to spread across. and where you want to place it. So general thumb rule of handling the private and public subnets, anything like internet facing would go into public, and anything your application specific where there is no need of internet communication would go into private routed via NAT. So few use cases, public can be of web server that would go in public. The NAT one, the NAT instance which you use, that would go into the public subnet. If you have a bastion or a jump server, that would go into a public, and whereas private, it can be your database servers, for example, that can go into a private, or if you have any internal application that you want to go with private. And there can be scenario where you want to SSH or connect to your private, or you don't want to open port 22 to SSH directly to the web server. So in that case, what you can do is you can come up with something called bastion server or jump server. So which will be your only server in the architectural design where you are going to open port 22, and that too will be protected only for your custom VPN IP address, so that it's not open for public. Only people can connect to your company VPN, and then they can connect to your bastion. And from here, they can try to connect to a web server or the database server based on your need, so that if it's all going to lie within the same VPC, it can communicate to each other. It's just that for a person from inside the internet to initiate the connection or initiate a request to your infrastructure, you need an internet gateway. That service will be like within a public subnet. But once it's within the same network, it's all they can connect and communicate with each other. So now you can design an architecture in this way, so that in future, if any attack you notice or some vulnerability notice, you can just shut it down, so that your web application will be still keep up and running. So this is the basic components, or like people should keep in mind when it comes to VPC, the components, the route table, and scalability wise. So in upcoming sessions, we'll talk more about endpoints, like how can we avoid communication from one to another via internet, those kind of things we see in upcoming. So any questions so far?